Good morning, good afternoon, good evening. Assalamu alaikum wa rahmatullahi. Depends on from where you are joining the program. We'll come back, to week number 6, session number 1, and today we are still in the process of understanding the data, pre-processing the data, making the data ready for our machine learning, our analysis. So I have to redesign the curriculum. It does not reflect where we are standing, but we are still in data preparation, data pre-processing. And in last week, we talked about about how to handle missing values and how to handle outliers. Today or this week, today and tomorrow, or week number 6, we are going to be talking about how to handle skewness, curtices, and also how to handle categorical data and how to transform your data from one shape to a different shape. So that is what we are going to learn, and by the end of week number 6, we should have a version that is ready, a version of the data that is ready for analysis. The first thing that we did is we imported certain packages that we know we are going to need to manipulate our data, navigate through data, visualize our data, analyze our data. So we imported NumPy or NumPy, Matplotlib, and Pandas. And we imported the data. This is what we did last week. So we got 21 features, and most of these features they are categorical. Simply means there is a lot of work we have to do transforming this categorical into numeric. The reason why we need to transform categorical data into numerical data, especially if you are using the algorithms that are doing calculating the distance behind the scene. So we need to transform all this categorical data into numeric. So these are all the columns we are using, and our target variable is the term deposit. This is why we're trying to learn, trying to map all the input, of the data to the target variable, trying to map age to target variable, job to target variable, marital status and education, and trying to find which features out of these 21 features, which features combined or a single or combined that would predict the term deposit or the target variable the most. That is what we are trying to do here using classification. That we'll be using classification analysis. Why we'll be using classification analysis? Simply because the target variable that we have here is a binary. So we try to classify a client as either is going to be a term deposit, yes, or non-term deposit, no. In other words, trying to predict a future client or future customer as either a 1 or a 0. That is, it's a class of 1 or class of 0. That is why it's called classification analysis. So then we looked into the first thing that we did is after, of course, we visualized the data. We completed file number 1, where we built data profile. We looked into data visualization. We built histograms, bar plot, scar plot, line plot. We looked into the statistical analysis of the data. So in the second file, we need to go deeper into statistical analysis for one reason, and that is to see if we can detect some missing values where the cell is not null. So, and we already covered this in the previous sessions, that missing values is not always an NA or an emptiness. So missing values always not, that's not the case. It's not always an NA or a none or an emptiness. So it could be a missing values in terms of zeros. It could be a negative value. It could be a garbage in there. So yes, we see here some zeros. This is something we might need to investigate further down the road to make sure that these zeros here do not represent a missing value. So and we are gonna need of course this is a team sport. Team sport means we are working in a team, and in our team we should have a business expert, a domain expert, and a data expert. So we need to call these folks here into a meeting and try to determine the values, the meaning of the zeros. So you got some negatives in there, negative values. Make sure that these values here do make sense. We got some, this is a target variable, we don't care about it. But we got some negative values, we got some zeros in there, we got some ones. Just make sure these values here make sense to you statistically before you proceed. Trust me, sometimes you are going to get some missing values in terms of zeros and negative values rather than having an empty set. And how do we detect missing values? There's numerous ways to detect a missing value in data. One of them is using the MSNO, stands for missing no library. And if you have a missing values library, of course you are going to get a lot of indication in your plot. So you are going to get a lot of indication in your plot. And this is a colored wise, and the missing values will be indicated. Unfortunately, we don't have any missing values. That is why we got only the bars, and everything else is being white out. So we don't see it. But this is what you were supposed to see if there were any missing values. So you are going to see a table of colored box indicating exactly the part, the part of missing values. You could see something like this, in the real scenario. Try it. Go to your data, remove some columns, or empty some what you call the cells or attributes, and try it. Then you are going to see some coloring in there. Let's take a look into this package. I'm sorry, so it's called missing no. Let's see if we are going to get there are a lot of possible options that you could add to detect exactly the part of your data that is missing. Okay, you are going to get a lot of. Here we go. This is what I was looking for. So you are going to get a nice colored heat map with some percentage, and it says here a value near -1 means if one variable appears, then the other variable is likely to be missing. A value near 0 means there is no dependencies between occurrences, and a value near 1 means if one variable appears, then the other variable is likely to be present. So you are going to see different numbers representing these missing values. So I'm going to share with you guys this document. Please go ahead and navigate through copy paste, copy paste, use the heat map version of it, or the endogram. Yeah, I mean, there's a lot of no, they have, yes, they have a lot of examples that you could use. So you could use so the code itself is there are 3 lines of codes, but you need to install you need to install the package first, then import from the package the missing the method, and run the method. And of course, you might need to change the method of display in the output. You could use a matrix, you could use a bar chart, you could use a heat map. I like this one is better. So the moment you see the color in there, it simply tells me that you have a missing values. So compare this one to the one that we have. So this is what, no, this is the original one, and this is the one that we have. We don't see the color simply because we don't have any missing values. Okay, another method of detecting missing values is using the SNA method. So bank application, which is the object where we have stored the data. SNA by itself will display a boolean, either false or true. And you see here, we got a lot of false, 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 false. And of course, this might not be a good option, especially if you have a larger data set. So what we have to do is we need to sum this boolean, and then we are going to get number of false versus number of false and true. Run it, and you are going to see age. We got a 0. All false means they are all we don't have any missing values. Jobs, no missing values. Marital status, no missing values, all the way to the end. So there is no missing values, and that is why you don't see any color in here, even though you try to change the output from heat map to bar chart. If you were to do bar, let's do that. Define. Okay. Here we go. So there is nothing in there. Okay, you could change the bar chart to the endogram to let's do matrix. Let's do a matrix also, and let's do the endogram. So yeah, play around this, and especially if you have a data set where you have some missing values. So play around it, learn it, and it has a lot of handy tools to help you understand the process of missing values. So here we go. So this is the bars, and this one is the matrix, and the third one is nothing in there, then the graph. But let's do an example. Yeah, this is our data. This is version number 2 we are using, and let's remove it now. Let's remove a couple of variables. Just play around, just remove, and remove some values and see if you are going to get anything meaningful. So I'm going to save my data one more time. Okay, I'm going to remove some ages. Here we go. And then I'm going to do Control Z because I want to make sure that, here we go. I want to make sure that my, I don't override my existing file. So back to the codes, Python Jupyter Notebook. So I'm going to read my data one more time. Okay. Take a look into descriptive analysis. Of course, we are not going to see, with descriptive analysis, you are not going to see the missing values unless you know the minimum, the maximum of your data, so you can compare it around. Yeah, durations, you got a 0 in there. Paydays, you got a 0 in there. Previous, you got some zeros in there. Okay, and now let's take a look into this animal here. See if we are going to get. Here we go. So now you see we got some missing values in there. And so now we got a nice graph showing that age, we got some missing values in there. And Oriborn 3, we got some missing values in there. So simply this missing no has a lot of handy tools to help you understand if your data has a missing or not. And if you are in a hurry, you don't have time to go through that, of course you could use this SNA sum. We just use, and we got 5. Age, we got 5 values. Job, we got multi, we got 2. Default, we got 1. Contact, we got 2. 4 and 4. Okay, one way to handle this. Any question before we move on into how to handle these missing values? Any question, concern, please? Class, if you guys hear me, any question, concern, please? Otherwise, I'm going to assume that everything is clear.
So, Brother Mo, so those numbers 2, 4 are the missing values, right?
Yes. So in age, we got 5 missing values. And now you have to determine what would be the optimal method of handling these missing values. Of course, you are not going to be able to build a model. You could build a model with missing values, especially if you are using some non-algebraic models like decision tree, random forest, bagging, boosting models. They're really they handle missing values very, very in an efficient way. But to avoid creating or building a bias system, we have to determine what needs to be done. So we have to see all zeros. And the easiest method is to do a drop everything that is in NA. So I'm going to run drop. So before I run drop, let's do so we are going to do shape to see how many features that we have. And we got 41,188, and we are gonna drop, and we are gonna calculate the shape one more time. Okay, drop means it's gonna drop 5 records from age, 2 from milestone, 1. Probably we could will be dropping over 100. There we go. So we got here 41,188, and now we got 41,173. So that is one way of handling the missing values. And another way of handling missing values, as we learned, let me run my data one more time because I already dropped them. Another way of handling missing values is We could mark the missing values, especially those where you have a special character, or where you have a missing we have a missing values by it's not a null cell. We could replace those special characters or zeros or negative values with the none. One thing that I learned, so we could also impute missing values. If you have categorical data, numerical data, we could impute the value or the variable that has missing values with the value mean, or the median, or the standard the distribution. We could, if it's categorical data, we could impute the missing values with the frequency or the mode. We could split the data. If you have, for example, you have 50%, so we got here, we got 41,188, and 40% of it age has a missing values, because that is a lot of missing values. If we were to drop them, is going to reduce the size of the data set that we are using. So dropping is not an option. So we have to either impute the mean or the median, and unfortunately, the imputation is not always the right thing to do. So I don't think it's right to fill out any missing values. Fill out 50% of the missing values with one single value. So it's there is a lot of biases around it. So the imputation, either with categorical numerical, it's done when you have a small data set, a small portion of your data that has missing values. Okay, we could split on that single variable that has a lot of missing values, and use learn from the first part and determine the value of the second part of your data. Something that I learned yesterday from someone who shared a document in the WhatsApp. Yeah, Miss Forest package. It does use a random forest behind the scene, and so anyway. Anyway, I'm not going to go through this, but I decided to include the code just in case. So the first thing you got to do here is you need to import, or you need to install the packages. It's called Missing Py or Missing Python. After you install the package, then you need to import the method you are going to use. The method is Missing Forest, and of course you need to create or initiate the imputer, then exclude your target variable, and impute and fit at the same time. So we are going to impute the missing values and fit all the missing values using the random forest. Okay, and you could use also the k-nearest neighbor. Now, k-nearest neighbor is another machine learning method to determine the value of missing values. But as far as I read, I know the random forest does better job than KNN. But it's totally up to you to find out, number one, to determine the best option. So number one, you need to find the type of missing values that you have. Is it Iqr, NAR, INMAR, MAR, and INMAR, and find out the value, the type and the value of the missing values. Is the missing values important? Are there too many? Then you could determine to predict them by using machine learning, impute them statistically, or simply drop them or map them and replace them. Okay, after that, the second most important problem that you need to handle is the outliers. Outliers, as we learned in the past, could deviate here from the reality. It could cause a lot of statistical imbalancing things about your data, and also it might not generalize well on a new data set. So we have to handle outliers, and we learned about multiple methods and that you could apply. Depends on the quantity of the missing values. If we have a lot of missing, the quantity of the outliers. If you have a lot of outliers in your data, you could split again into two parts. One part with normal data set, which is normal data set, and the other part, which is the abnormal part of the data set, and use models, the same model, and average them. You could also normalize your data to reduce the distance. You could, but to determine if you have missing values, you could use graph test. So I get the codes, and you could use a box plot. You could use Iqr Score. You could use again a z-score. The value, if you were to use a z-score for a value, so we are looking for an output between -3 and 3. Anything above 3 and anything below -3 or above 3 is an indicator that you have you have outliers in that particular article, feature. Okay, and now what to do with skewness? So again, when it comes to skewness, there are two type of skewness. Actually, there are three. So let's assume that we have here age, age, and age, and we got here count of age, and count of age. So when we plot this age into 2D space, yeah, you are going to see the distribution of the age. So the optimal distribution we are looking for is the one that looks like a bell. It's called bell shape, also called normal distribution shape, and sometimes it's called the Gaussian distribution. So this is the optimal distribution we are looking for at this particular age. And the value of the skewness, if you were to calculate it mathematically, is going to be equal to 0. So the skewness is equal 0. So either look for visualize your variable, or simply calculate the skewness and to help you determine the type and the shape of the skewness, the distribution. So another shape is going to look like this. So as you see, it's skewed. It's a negative skewness, negative skewness or minus. So the value of the skewness is always going to be less than 0. And the positive is going to be the opposite of the negative skewness, something like this. So it's skewed to the right. So we got some problems in the right tail. Got some problems in there, and for the negative skewness, we got some problems in the front tail. So this is positive. and the value again is greater than 0. Okay, so this is what we want. This is bad. This is not. This is bad. This is not really. This is not ready to go data for analysis. You still can use skewed values in your data, but be careful. Be careful. You might be careful because skewed variables could cause some deviation from the reality. It could cause a lot of bias in your finding. So how to handle that? So let's take a look at to find the skewness. There's a lot of methods we could use. Yeah, to find the skewness, we could use the Shapiro library. So we got for age, the skewness is 1. Simply means we have some skewness in there. So I was expecting a 0, so now it's a 1. So now from so this is the package or the method we are going to use, the Shapiro from SciPyStat. Let's see if we have any document to share with you. PDF. Okay. Yeah, I'm looking for PDF. In most packages or libraries in R, you have a PDF. In Python, it's no, the most you are going to get is a reference to a link or a website. So let me see. Yeah, I think we need to spend some time to search for a PDF. But anyway, this is the package, and I was looking for a specific thing about the skewness. So we the age is not skewed. As you see, so this is the density plot of the variable age, and as you see here, we got a lot of we got a lot of problems in there. You can tell if there is a problem. So we got some problems in there, and of course we might have some outliers, definitely. Okay, so what do we need to do? Of course there are a lot of techniques. There are a lot of techniques that you could use to transform your missing values to a non-missing format. Okay, skewed. So you could also use a skewed method to look into the skewness around all your numerical data. So this is what we have here. The campaign is high skewed. Previous is 3.3, duration 3, age. For reason I think we got a 1 here because it was rounded. So it's actually the value of age is 0.7, it's 0.8. And the others we got a negative. So all of the features here they are skewed. So one way to unskew, of course, it depends on the type of the skewness that you have. So if you have a positive skewness, there are a few techniques that you can use, and if you have a negative skewness, there are other techniques you can use. There are some of the methods that you could use to handle the skewness, and we are going to implement some of them today. So again, so if it's for positive skewness, so if you have a value of the skewness that is greater than 0, so you could use, you need to divide and subtract. You could use the transform method, you could use the multiplicative method, and square root transformation method, and of course there are others. So this is the log method. So let's say in our example we have age equal 0.78. So we are going to do we are going to do a log. This is the way we are going to do log of age, or we could do a log base 2, log base 10. We could simply take 1 divided by age. We could do a square root of age, that would reduce the skewness from 0.78 to a value closer to 0. Any method of this will work. You don't have to do all of them, but one of them will work. And sometimes as a data scientist, to determine the optimal method of transforming the skewed variables or reducing the skewness of a variable, you might need to try them all. Yes, that is your job as data scientist, is finding the optimal. So you could log transform your skewed variable and build a model, then do multiplicative transformation, build a model. You could do a square root, build a model, and determine which one yields a better performance. That is how you determine the best performance for a specific problem and specific data. So if you work on a project and you find out the log transformation is better, don't assume that log transformation always going to be the better option for your future projects. So your job is to try and keep trying until you find the optimal solution for whatever challenges you are struggling with in terms of data quality. So if it's positive, we are going to use log transformation, multiplicative, inverse, or square root transformation. And if it's negative, then we are going to go upward. Then we are going to use square, cube. So we are going to raise the value of the skewed value to the power of 2, power of 3, and we keep raising until we find the optimal skew. So in example that we have here, so this value here, this object here, or this feature here, is a very skewed, and it's a negative skewed. It's minus 3.4, and this is the original x. Then we squared the x, multiplied x to the power of 2, and we reduced the value from minus 3.4 to minus 3.3. Then we did 3, 4, 5, and we did 20, and we reduced it from minus 3.4 to minus 1.6. It's better, but we are still having some problems in there. Then we keep scaling. We keep scaling the magnitude of the value over, and we multiply it. We multiply. We change we multiplied by a power of ID, and now we got a 0. So this is normally distributed. So instead of using the original x, which is age, we are going to use in our example age to the power of 80. F a in the skewness of age is a negative. But in our example, the skewness of age is positive. Age is positive, so we are going to do here the square root transformation and reciprocal transformation, log transformation, and there are other method of transformation. So what we are going to learn here for one single one single animal could be could be the same, could be applied, should be applied with all variables. Okay, let's take a look into the age again. What is age? Okay, it's rep. So the representative here. So what we did here, we created an object which is a it's a represent, or and we assigned to it the value of age. And so this is the original data set. As you see here, the skewness is 0.78, and now we are going to take age, and we are going to multiply it by 0.5. So this is the square. We are going to get the square root of the value age, and we are going to display it. So this is the original, as you see, and now this is the square root of the original. It did not fix it. We still have a lot of problems in there, but if we were to use square root, is way better than original data set. And for the reciprocal transformation, we are going to take 1 and we are going to divide it by age. It's 1 divided by age. That is the inverse. Yeah, the multiplicative inverse, 1 divided by the value you're trying to figure out. Okay, let's take a look. Yeah, I mean, I think it creates some missing values. You see there is a lot of I think we have some missing values, and we have an outlier. So it did not really it could have solved the skewness, but it creates this inverse or reciprocal transformation method. It could have fixed the skewness or reduced the skewness, but this is something very important here. We are going to do
more instead of visually seeing it, should we not use this function skewness?
Yeah, that's what I'm trying to figure out.
Okay.
Type object skewness. Yeah, we could use only this one. Okay, let's do that. So we are going to calculate the skewness first. Okay, so we are going to calculate the value age. Why is age? Age. I don't need to sort. Just calculate the. So this is the first transformation is the square root. So the original skewness of age is 0.78. Then the skewed, or I'm sorry, the transformation, the square root transformation dropped it to from 78 to 44, 0.44. It's better, but we are still having problems in there. Okay, and now we are gonna do a reciprocal. Okay. I got it. I got it, brother.
Okay, thank you.
So actually, it did not. Yeah, this is what I was expecting. The reciprocal did not fix it, so it makes it worse. So it jumped from 0.78 to 1.27. That's why we got some outliers in there. You got some missing values. So the inverse transformation, the inverse multiplicative inverse transformation is not a better option. So now we are going to try the log transformation. Let's try the log transformation and see what is going to happen. Okay. So we got the original is 0.78 and the log transformation is 0.12. So out of these three methods, which one you think is better for our specific example? The square root transformation or
The log.
reciprocal transformation, log transformation? I think we should go with log transformation. Of course, we still have some problems in there. So we need to be careful about the missing values, and we need to be careful about the outliers. It does really reduces the skewness of the age variable or age column dramatically from 0.78 to 0.12, but it does create some problems. So you might need to first, before we do transformation, we might need to handle outliers. Yeah, we might need to handle outliers. Okay, any question, concern about this?
Basically, you're saying from this data set, you handle the skewed data, then you handle the outliers, and then also the missing data, right? You could apply all of them to clean up the.
Yes, I mean, yeah, I think before I think you should start with before you transform the skewness, you should remove missing values and outliers. So
okay, because it looks like the skewed data is introducing new missing values and new outliers, right?
yeah, because we have an outliers in there. That is what's.
We didn't clean the outlier. Okay.
No, we did not. We simply learned how to handle outliers, but we never.
Okay.
Let's try it. We are not gonna. Yeah, let's try it to see what's gonna happen. Okay, let's take a look into Dropbox missing values. Outliers of the age. So this is age. So we got a lot of missing outliers in there, and we are gonna do age. Let's do this. Okay, and I know you are going to see a huge difference between transforming data with outliers and transforming data without outliers. It's going to create a lot of difference. Here we go. This is a better. Let's make sure that. So we got here. We are going to use this our insurance copy. Okay, so instead of using the bank, we are going to use let's take a look. I don't want to change this. I'm going to do. Outliers. Age outliers. I'm going to remove. Age outliers have been. Okay, do you guys understand what I'm doing? Do you guys understand what I am doing?
Yeah.
So if you guys remember, before we removed the outliers, what was the skewness of age?
0.7.
Yes. So now by removing those, by simply removing outliers, it reduces the skewness. And now let's take a look into transformation. So we are going to transform using the square root first. So we got so now it's 21. Then we are going to use a reciprocal or the multiplicative inverse. It's no, this is no, worse, and this should be better. This should be way better. 0.12. I'm expecting to reduce it closer to 0. Yeah, here we go. It's a negative. It's almost 0. Okay. So the first thing you gotta do here before transforming your data, so we need to look into before transforming your data, we need to deal with missing values and outliers. Not only for for all your data set, so you need to reduce to audit the quality of your data before transforming it. Otherwise, you are going to see a lot of problems in there. We still have a few outliers in there because we cannot handle all the outliers, but it's better. Now it's better. Okay, any question, concerns about transforming positive or negative skewness?
Can you quickly show us how do you remove the outliers more when you replace bank
So
app with the other?
this is one method. This is one method. Is calculated the IQR. Yeah, where is it? Yeah, so this is all I did. So number one, we looked into the value, which is just simply to see if there is outliers in there. Okay, and we created an IQR score. It's simply difference between the highest whisker, the maximum whisker, and the minimum whisker. So the IQR difference between them is 15. And or the IQR is 15, then we subtract this value here. Yeah, so we multiplied the lowest variable of our data. I'm sorry, we use the 25% of your data, then we subtract from it the IQR multiplied by 1.5. This is the formula. Then the lowest value is 9.5. This is the outlier from this is the lowest outlier. Then the upper fence, or what we call the upper Whisker is the third quartile. So this is this is the first quartile is 25%. This is the third quartile of 75%, and this is the minimum, the maximum Whisker. This is the minimum Whisker, and we have here the mean. So we took the 25%, then subtract from it minus minus 1.5 to the power of the IQR, which is 15, and for the 75% is the opposite, is plus. That's all why we did. Yes, quartile 3, 75% of your data, plus 1.5 to the power of IQR. And after that, we made a copy. Then after that, we simply created a new version of the data to include all the features except features that they are lower, except the elements that lower that less than the 9.5, and feature that above 69.5. This is how we remove. This is one method of removing the outliers using the Iqr scoring. Of course, there are other methods that you could use. So now this is the I believe the Iqr. This is the box plot before implementing the outliers removal, and this is the final version. So now you see here we don't have any outliers, but the center of the data is not normal. You still have this is not normal. You can tell, we got a lot of data above 50%. Okay, so Khan, did I answer your question?
Yeah, I understand now, because I was sure about when you replace bank apps with AU copy, that's what I wasn't sure, but I got it. Thank you.
Other questions, concerns about dealing with skewness? Any question, concerns, please speak up, don't be shy.
Hi, Mo, this is Dan.
Yeah, Dan.
So when you use the log method, there were missing values. Like, do you go back and fix those?
Yes, you always need to check and double check to make sure that when you transform your data, you are not creating other problems. Just to be on the safe side, always double check what your work. Don't assume that, because don't believe blindly a method, any transformation method. Just once you run it, double check that you are not creating other problems. Okay, Dan, clear?
Yes, thank you.
You're welcome. And the same applies to all skewed features. This is only one. We are doing age. So you could do the same on the campaign, previous, etc. But before we do this, what do you think you should do? Before you spend time fixing these features in here, what do you think you should do? It is a critical part or a critical step that you have to take to save you a lot of time, a lot of energy, a lot of effort. What is it?
I think we need to discuss with the business folks and try to understand how important that very data is in our final value.
And I don't think the business is going to help you. Yes, you are right. We need to determine how important these features are, but you have to determine how important these features are scientifically. Okay, you have to do it scientifically. I hired you as a data scientist. I don't know how mathematically the campaign is important. That is something that you need to determine. Of course, it's always better to consult with the business, with the data expert and the main expert, but it is your responsibility to determine if a value is important or not. And we already covered few methods. Can you, Idris, you remember them?
Yes.
Okay, well, what are they? We already talked about few methods to determine if a value is important or not important. We use the prior knowledge. Prior knowledge is simply removing anything that is an ID, anything that is constant value, and anything that is personal information, like social security numbers, names, addresses, email address, etc. So that is called prior knowledge. And also we use the correlation analysis. And the correlation analysis, when we are looking for a correlation between X and X, we are going to eliminate anything that is equal or closer to 1, and we are looking for X and Y. We are going to eliminate that is something that is equal or closer to 0. And of course, the conditions of using correlation: number 1, you have to have some linearity in there. Number 2, we have to have real values. Number 3, we have to have a pairs. And number 4, we have to have a numeric values. So these are some conditions to have a better understanding of your correlation. So this is called the primarily feature selections. Okay, so before you spend time transforming age, make sure that age is important. So using your prior knowledge and correlation analysis. Of course, there are other techniques that you could use, and which we are going to learn either today or tomorrow. Okay, any questions, concerns about this, please?
So when we transform that age and remove the skewness, what did we do actually? We're going to replace the previous age with this new transformed number?
Yes.
Okay.
So if you find out the log transformation is better, then age is bye-bye. So we are going to replace the age with the log transformation of age, with the log of age. So that's what we're going to do. Yes, we are going to replace.
We're going to update the CSV file?
No, you update the file in the memory, not the CSV file. Okay, and the same applies on all other features. Okay, so that is how you handle the skewness, positive skewness or negative skewness. For this negative skewness. So
hey,
yes, sir.
One quick question.
Yes.
So you have this data set, and then we applied different methods to identify the skewness, like log, reciprocal.
No,
but
these methods, they are not. This method you just mentioned, they are not to indicate or your skewness. They are to fix your skewness. Just correcting your terminology.
Okay. So if my data is dynamic in nature, how we can know like which method will give us the better results?
Good question. So if your data is dynamic in nature, I don't think so. You might need to use some big data technology. If you are doing this on the fly, online or near what we call it. There's a terminology used. If you are handling if you are doing analytics in real time, it's going to be so hard, and it's going to be so hard to try using this machine learning techniques. So you have to use different scenario, and that where big data comes into the play.
Right.
These methods that we learned here is applies would be applied better for any batch historical data. Real time, it's hard. It's going to be so hard to apply any of this, because sometimes you'll get. But regardless, I think this method would work also. Or what it does, it looks for, let's say that you are working on real-time data where age is not an object, and age is a feature. And so what it does, number one, it looks into the skewness of age, and you could put in there a script. You could put in there a script that determines that looks into the skewness. If age is positive, then transform it using the square root and reciprocal and log transformation 3. So this is I'll give you a scenario. So let's say that you are doing it in real time, and you have a value called age. Okay, so this age here will be we are going to have some pipes in there. We are going to have a pipeline. So you could code, you could hardly code this. Okay, so you feed your age to the pipe, and we are going to have an F code or F statement in there. So number one, this age will go through the skew function, and of course we are going to get a value. We are going to get 3 values. We are going to get 3 values. Less than 0, equal 0, or greater than 0. Okay. So if it's equal than 0, you are going to have a lot of F in there. F equals 0, pass. F greater than 0, then we are going to do square, then we are going to do multiplicative inverse method, then we are going to do log method. Okay, then we are going to compare. We are going to compare the output of the 3 methods. And with the 0, and keep and will apply a method that reduces the original the original value to 0, original skewness original skewness to 0. So it's all an if statement. If skewness is less than 0, then we are going to try a range of power from, let's say, 2 all the way to 100. This is something that your developer could help you, and you could do it also. And we are gonna keep the power that reduces the skewness better, or at least closer to 0. Okay, that is going to be in the pipe. So all this should be a code that you are going to put somewhere in the pipe, and finally you are going to get a transformation. Transformed age. So we started with age, which is highly skewed, and now we got a transformed. So we start with with an age, and now we got transformed age. I think you could do it even with the real, in the real time and near real time data. So you get the variable, you get the object. So you pass it through a pipe. This is called pipeline. And you calculate the skewness. If it's negative, if it's the skew equal closer to 0, just pass it, no transformation. And in your data set, let's say that you have variables like this. So you get age, you get here, income, you get here number of days, and you get here different variables. So you take a value. The first value will go through the pipe. We are going to calculate the skewness. If the skew is equal to 0, then go to the next value. If the skew of the first feature is positive, then do square root, multiplicative inverse, and log, and compare their output, and choose the one with the highest output and transform. Once you are done, then try the income. So that is one method of handling the skewness on the fly. Clear?
Mo, you said 0 would always be ideal. So should we assume that anything greater than 0.1 start using this, and anything close to 0.1 or less would be considered equal to 0?
Yeah, you could do that. 0. 0 is an ideal, of course, but you might not get it. So anything around, but if you are working, it depends on the sensitivity of the project you are working on. If you are working in a pharmaceutical project, or a healthcare project, where the human behavior or human you are testing a human, something on a human, so it's very sensitive, because even a small tiny skewness in your data could cause a lot of health problems. Mm-hmm. So if the project you are working on is very, very sensitive, I think we need to make it as 0. Okay. If you are working for a churn problem with the bank, or any non-human, I would say, analytics, so I think the tolerance is wouldn't matter. So we could do anything that is. So we got a 0 here. So this is the skewness. got -5 to probably 5. So anything in this area, I'm fine with it. Anything minus 0.02 and 0.02, I think we should live with it. If the case you are working on is not very sensitive. Okay, yeah, you could code, you could hard code this in your pipeline.
Yeah, makes sense.
But this is the scenario. This is the scenario you are going to do. Regardless, if it's the missing values, you are going to do the same. If it's outliers, you are going to have a pipeline for before the pipeline of transformation. We could create one pipeline for missing values and outliers, because of course that is a prerequisite for transformation. Then we transform. If it's non-numeric values, we need to transform them first for numeric values and apply the pipeline also. But yes, this method that we learned today could be applied on the fly, could be applied on real-time data. Okay. So of course, you could also do box-Cox transformation. The code here is grayed out, so please, and most of the code here we are not going to use, unfortunately, but I decide to include this in the template. Probably, you never know, you might end up using them. Sometimes you might need to decoratize your data, especially if you have a large data set. I'm sorry, if you have decortizing is the opposite of transforming categorical to numeric. So you could use it to reduce the amount of computation. We could use a binarize. If you have a value with yes and no, you could transform it into 0 and 1. Box-Cox, again, it's another method for transforming and reducing the skewness of your data. You could convert a class into an integer, and so tomorrow we are going to do scaling, and we are going to do categorical transformation, and we are going to do feature importance, and of course we are going to save as version number 3. So then we are going to save for version number 3, and the following weekend we are going to start building a machine learning. So let's stop here, and let me see if you guys have any question and concern before you got dismissed. So I need some dialogue here. So please interact with me and ask questions. If there is any doubt, any concerns, any question you might have, there is no stupid question, please ask them. We'd rather it's better for me to stop and make sure that everybody is in the same page, rather than simply going through this information and trying to complete the program. So any question, concern in terms of transforming the skewness, the positive skewness and negative skewness? Okay, going once, going twice. Thank you guys for the business. I'll talk to you tomorrow. Until then, you might have a great the rest of the day. Bye, everybody.
Thank you.
Thank you, sir. Bye-bye.